Alright, so today we're going to be talking about the carbon cycle. And basically, just on a very surface level, the carbon cycle is just how carbon is moving through the atmosphere, the plants and animals, the ground, and the oceans. Okay, so we've got a couple different diagrams that we're going to be looking at. And as you can see here, it says that the carbon flux indicated by arrows, so, the direction the arrow is pointing is the direction the carbon is going. And there's the natural flux that happens all the time anyway. And then there's the anthropogenic flux, which is basically human contributions and human changes in the carbon cycle. So we've talked before, we know that carbon dioxide is in the atmosphere, and we know that it is a byproduct of cellular respiration. So anytime any organism goes through cellular respiration, they exhale carbon dioxide, even plants. Plants then do use that carbon dioxide in photosynthesis, but in cellular respiration, all organisms give off some carbon dioxide. Carbon dioxide is also a building block of organisms. It's basically, we're carbon-based life forms. Our body chemistry on a chemical level is constructed of a great amount of carbon. So that is all here, and it was all put in place in the right amounts at the right times by God when God created the world. And so now let's, in God's design, let's then look at the natural flux. So we have, I'm not exactly sure what the units are, but we can at least compare the numbers. So in the atmosphere, we have 730 units of carbon dioxide, or carbon, not specifically carbon dioxide, but carbon in the atmosphere just floating around all the time. Now, in normal circumstances, 90 of those units are going to go into the ocean, with waves and everything. There's constant gas exchange between the atmosphere and the ocean. The waves are going to pull in some of that carbon dioxide, and then that's going to get mixed around. It's going to get used by different organisms, such as snails and scallops and other crustaceans and things, to build their shells or to build their homes. And so then that's going to be going into the ocean. You can see the ocean has this reserve of 38,000. Now again, there's also like vents underwater from underwater volcanoes and things like that. So that's adding to the ocean's carbon reserves. Now we have this arrow going up under normal circumstances, again with waves and general gas exchange. The ocean would then give off about 88 units a year. I guess we're talking about per year, but per unit time. So now, one of the things that's happening, since we do have greater temperatures, more water is going to be evaporating. Now, as more water evaporates, the ocean is going to be giving off more carbon dioxide, and that is one of the sources of increased carbon dioxide in the atmosphere. Although you can see here, we've got 90 units going into the ocean, 88 units coming out, so they're very close, but at the moment we are still building up additional carbon in the ocean. Now we also have the global gross primary production and respiration. So all the plants and animals in the world are absorbing through, plants' photosynthesis or through organisms' growth. They're absorbing about 120 units of carbon from the atmosphere, and then they're giving off about 119. So again, very, very similar, almost level. And then again, just like in the ocean, we have this reserve of carbon that is in the vegetation and the soil. The trees have to come from somewhere, and a lot of that material that makes up like tree trunks and things like that, even blades of grass, is carbon. Now we're going to get into these red numbers. Okay, so now let's look at these red numbers, the anthropogenic flux. And this is really where the issue is arising. Over here we have changing land use, and so this would be things such as, clear-cutting forests to make way for cattle ranges and things like that. Using those trees, that is going to change the amount of carbon that's being used by plants and animals, because it's going to change how much is there, and it's also going to be changing that reserve when we're burning those resources, those trees and things like that. And then over here we've got the fossil fuel combustion and industrial processes, and that's adding 6.3 units of carbon to the atmosphere. So this is the main number that is, in question, and that people are saying is adding to the carbon content of the atmosphere, because you can see all these other numbers are fairly small. Well, 6.3 is fairly small, but they're also fairly even. 88 versus 90, 119 versus 120, 1.9 versus 1.7. Now on this one with the changing land use, we're actually, theoretically using more carbon than we're giving off, but still very, very close numbers. But over here, when we start to talk about the fossil fuel and combustion from the industrial processes, there's nothing to balance it out. So that's where the environmentalists and global warming activists really get concerned, because we don't really have anything balancing out this 6.3. And so they really want to get this number lower, so that it has a smaller effect on our atmosphere. Okay, so now let's look at another diagram we have. Now this one is, I believe it's in billions of tons per year. All these numbers are in billions of tons per year. And the yellow numbers are natural numbers. This is what happens naturally. The red numbers are because of human involvement, and then the white numbers are reserves. They're not getting exchanged, they're just there. For example, we've got this fossil pool down here of 10,000 billion tons per year, or 10,000 billion tons, which would be our fossil fuels, which, as we talked before, are just all those plants and animals that got buried in the flood. We also have a nice reserve in the soil itself of 23,000 billion tons, and then in the deep ocean and reactive sediments combined, that's about 42,000 billion tons. We have surface ocean, that's about 1,000 billion tons. Plant biomass, again, just the structure of all the plants that we have. So we have then, okay, so the arrows show where the carbon is coming from. So initially we have the photosynthesis that is taking the carbon out of the atmosphere, bringing it into the plant biomass, and eventually down into the soil. Then we also have plant respiration, that's cellular respiration, that gives off carbon dioxide. So the photosynthesis is taking in about 120, and then it's plant respiration is giving off another 60. And so you think, wow, trees are really going to suck up all of the extra carbon dioxide, specifically in the atmosphere. But then we come down here, microbial respiration and decomposition. When all those plants die, we get that balance. We get that other 60. So in the meantime, it's stuck in that biomass, so it's fine for now, but when all these plants die, it's still going to be put off into the atmosphere. Okay, so over in the sea, again, we've got the carbon coming in from the atmosphere. It goes round and round and round. The ocean eventually absorbs 2 billion tons per year, and then gives off about 90. So we had 90 from nature and then 2 from us. The ocean absorbs 2, gives off 90, so those numbers balance. And then over here, the net terrestrial uptake is about 3, and that works with that 3. So all of our numbers balance pretty nicely, except here, according to this diagram, let's see if this shows nicely, we have this 9 extra. Now remember, this is 9 billion tons per year, so we have 9 billion tons of carbon that's going into the atmosphere from fossil fuels, cement, and land use change. So overall, that adds up to a 4 billion ton net annual increase of atmospheric carbon. So that is, you know, I mean, when you look at it and you have those units, it really changes things. But one of the things to consider is, you know, just the general cycle of the Earth. We're coming out of, we're still on, they're basically, if you look at, I think they're called, you know, climate, if you look at, you know, climatology from the last 1,000 years, if you look at the general climate from the last 1,000 years, we are, hold on, sorry. Okay, so we have this last 1,000 years from 1,000 to 2,000. We'll just, you know, forget those extra 15 years for a moment. Okay, so from about 1,000 to about 1,400 years, the average temperature of the Earth was actually increasing, just like it is now. And there was a lot of CO2 in the atmosphere, and this in Europe was actually a very plentiful time. There were lots of plants growing. As we read in some of the articles this week, when there, you know, we have this extra CO2 in the atmosphere, it really helps plant life. They're able to more efficiently use the water that they have around them, even if there isn't necessarily a change in the water that there is available. They're able to use it better. There's a lot of lush plant growth. We've been seeing that recently. There, at this point in history, from 1000 to about 1400 AD, there was a lot of plant growth, lush plants, bumper crops, all of that. There was a spike in the economy and all of those nice beneficial things, and clearly, you know, the world didn't end in 1400 AD. Also mentions that Vikings were able to settle Greenland. There was a lot of expansion. It was just a good time for, you know, humanity. Then, due to, you know, the natural cycle of things, the temperature started to drop, and these are just arbitrary lines, I'm not exactly sure the angles, until about the 1800s to the 1900s. The temperature dropped, crop production decreased, the economy decreased, people were forced to move farther south out of northern regions because the ice caps were coming, and this has actually been called a little ice age. It wasn't massive. We didn't have, you know, animals changing. It was only 400 years. It wasn't a big impact on humanity or animals, but, you know, the temperature did start to lower. That is not even remotely close to scale. Sorry. I need to fix this. Okay. So, this would be more like 400. Well, I guess, yeah, that's about another 400. It's this line that needs to move. Okay, so we had our little ice age, and now we're at the start of a warming trend. So about there. Okay, so this is a cycle that people have been seeing, and, you know, the Earth goes through lots of cycles, and this just looks like another part of that cycle. We had a warming period and then a cooling period, and now we're having another warming period. And actually, it's looking like a lot, since the Earth is warming, it looks like a lot of this CO2 could possibly be coming from the oceans, because as oceans get warmer, they're going to evaporate more, and that's going to release some of that CO2. And then when it gets colder, like in this period, the oceans are there's going to be less evaporation and even more condensation from the atmosphere back into the oceans, and that's also going to pull in the CO2, reducing those levels. So the Earth is, getting warmer very minimally. Now the question is that something we've caused? Is it a problem? Or is this just a natural cycle that the Earth goes through?